Alright, welcome to episode 4. Not sure what I really want to do. I'm thinking, why don't we make the game Falldown? Because for some reason I just kind of thought, I've made it only like once before on a calculator, but I want to try, just challenge myself, do something a little creative if I can. So anyway, we're gonna go create a new game. We're gonna call it Falldown. And here we go. So as usual, let's just clear the screen. Let's go ahead and we'll give our character some coordinates. So let's start him at the top. So it's going to be 1 stores y, and we'll try to put them in the middle, so 8 stores x, and then we'll output a theta to be our character, and then we're going to move him down every cycle if we can. If there's no wall beneath him, we'll move him down. So either he'll hit the bottom of the screen or he'll hit some kind of wall, and then our 2 moves should be able to be left and right. So let's go ahead and do that. Let's use A just like we did before when we did Zelda. We're going to store A into 0 into A, then get key into A. And then we're going to check if it's 25, then we move right. And if it's, I'm sorry, that's going to be 26. And if it's 24, then we move left. And then we want to add 1 to y. So if y is less than or equal to, we'll say is less than 8, then y plus 1 store is y. And then we want to do a loop around all this, so it's going to be a while 1. So we'll just, for now, we'll just play the game indefinitely. Okay. Uh-oh. What did I do wrong? Oh, I was displaying what theta's value actually was. Here we go. Okay, so I can move left and right now I'm stuck at the bottom of the screen. So that works. Let's go ahead and store the old coordinates. So x is going to be stored into s, y is going to be stored into t, and then if, or I'm sorry, here we go, if t does not equal y, or x does not equal s, so we're checking if the new coordinates are different, then we're going to output a space, and then and that's going to be in the old coordinates, so we're going to put a 1 and an 8 stored as t and s. So there we go, we erase ourselves. It seems to be working just fine. So now let's move on to a wall. Let's make a wall that moves up. So we're going to do a matrix check actually. So because I want us to be able to keep this 3D, I want to be able to go basically anywhere, not just in one, not just in one section of the screen to where we're going to use a list, but I actually want us to be able to hit walls at any height. So we're going to use a matrix so that we can test, no matter where we are, the screen will always have a set of given like walls that we can hit, just to keep things simple. And then we're going to fill this matrix obviously with 0, and of course now we're going to have to, every probably couple cycles or so, we want to actually move the ground up. So let's actually put another loop around this, and this is going to be kind of like a delay. So I'm gonna use b as the variable, and I'm gonna take it from 1 to 50. So basically we'll be able to move 50 times for the walls to move once. Now what's nice about this is I actually can change b. I can make b bigger or smaller, so I can make the, if I wanted to, I can make the difficulty slowly increase just to ensure that whoever's playing will eventually lose at some point, and we can try to make some kind of like high score system or something. See how many loops you can get through before you have to quit. So we're gonna basically start with some kind of wall here. So this will be the section of code where we input a wall. So matrix let's do a loop. So for C, we're gonna use C. C is 1 to 16. And this is where we store we're gonna store 1 and 2. Oops, this is the wrong side of the matrix. We're gonna store 1 and 2. The y coordinate's gonna be 8 here because we're putting it at the bottom of the screen, but C is going to be 16. So now let's choose 2 random spots. They might overlap, which is okay, because we'll still at least have 1. But yeah, let's do 2 random numbers here from 1 to 16, and these are going to be holes that we can jump into. So actually I'm not going to store those. Those are going to be part of the store statement. So I'm going to store 1 into matrix A, 8, and then 1, a random number between 1 and 16. So we're basically, oh I'm sorry, not a 1, a 0, because we're basically trying to say, okay, we want a full wall there, but then we're saying like, oh wait, we want 2 holes there actually, just random holes. So actually if we were to run, well, shouldn't run it yet because we can't see it, but we can output, I guess, a I suppose we could output everything. Yeah, so I can go through a loop, and we'll clear the screen here, and we'll just output. First of all, we'll output our our little guy, just to make sure he's on the screen. Actually, no, we'll do that after. So you know, we don't need to clear the home, actually. I'm wondering if I should change this, because we might get stuck. We might not be able to move. So this is what I'm thinking. I'm thinking we'll leave this algorithm in here, but I want to make it so that you can move around even while the screen is printing. So actually, I'm going to change the B up here. I'm going to do it from, I'm going to do 2 loops actually. And I'm going to say for G and H, G is going to be 1 to 16, but H is going to be 1 to 8. So I'm going to actually loop through the entire screen. And when the screen is looped through, that's when I'll actually put another, not there. That's when I'll actually go down here and make another floor. But up here, after we print, or after we change our coordinates, that's actually, this is actually where I'm interested in outputting. Would it be here? Yeah, we'll just put it here. So we're going to output H comma G. And then we're going to output matrix A. Let's see here. We're gonna do what we usually do with the string. Store blank into string 1. But if matrix A of H comma G is equal to 1, then we're going to actually put circles into string 1 instead, and then we're going to output string 1 to whatever position that is. So now if there's any walls or anything, we'll be able to move around once for every pixel that's being drawn on the screen. So let's see if this works. I believe it's drawing right now. So if we wait long enough, it should draw on the bottom of the screen. Oh, there we go. Okay, so right now it's drawing on the bottom of the screen really slowly. Yeah. So this is probably not a good way to implement this because it's really slow. I'm trying to remember what I did to make this go fast. I don't think I used a matrix. I think I used lists. And basically the way the lists worked were, or no, I think I used variables. The way the variables worked were there was a guaranteed level that went up the screen. At every other instance there was always like a level, and so I didn't actually have to program that there was a wall there with a matrix. I just had to program hard code in that, you know, if it was one of the two states, whether the wall was on the even rows or the odd rows, then you would get trapped on the wall unless your horizontal coordinate was equal to a certain variable, which the variable held where exactly that space was. So I'm pretty sure I did something like that. I don't know if that's exactly how I did it, but I know I was able to get it in one run. So it looks like I don't know, this might be a failure. This might be my first failure. Because there's no way we're gonna get it. There's no way it can be that slow. Maybe what we can do is print one. I'm wondering if we can print one row at a time, if that'll speed it up. That might help. So if I just do H is 1 to 8. And then I do a G is 1 to 16. And then I loop it. In here. That might speed it up a little bit. Because okay, good. So we're going slower, which means there's a lot faster. It's doing the rows a lot faster. But I don't want to be that slow. I want to be more in control of what I'm doing. But that is good. We might be able to go with it for now. Maybe I can do a faster one later and then show it. I'm not sure. But let's just go ahead and try this. So yeah, after that iteration, what I want to do is I want to move everything up a row. After that row has been drawn, I want to have a variable for switching, so we're going to use M. So we're going to store negative M into M. Okay. So if M equals 1, then we'll do this. Otherwise, we're gonna instead of drawing a new line, we're gonna move everything up. So that way we move. Actually, no, because we'll be drawing a line every single time, then moving. Yeah, so let's move up every time, but only sometimes we'll draw a line. So sometimes we won't. So yeah, let's do that here. Let's just do this every time. So I'm going to go through a loop. Let's see here, for B is 1 to 16. I'm going to do 2 ends in another 4. Actually, instead of B and C, let's use L and let's just use Q and R because they're next to each other. 1 to 8, and let's not go 1 to 8. Let's go 1 to 7, and then yeah, we'll store 0 into the bottom row. I'm kind of disappointed that I did this down here though, because I just realized I want to move everything and then I want to draw the row. So actually I want to do that up here. So let's do it in front of the negative m's. So let's do the 2 for loops. Q and R. And we're going to store as we're going to basically copy everything, and then we're going to clear the bottom row. So we're going to store 0 into (8q), but we're going to take whatever's in each row. So R plus 1 and Q, and we're going to store that into the one above it, which is just R. Okay, so it should form a bottom, and then the bottom should go up. And it's not working. So that we have a problem. Q is 1 to 16, R is 1 to 7. So let's look at our matrix. It's completely zeros. This is appeared. Oh, I know why. This is completely my mistake. I forgot to initialize m. So we have to store 1 or -1 into m. It doesn't really matter, but m was obviously not 1 or -1. And yes, it was 4. So there we go. Let's see if this works. Should draw. There we go. Okay, now hopefully it moves up. Yes. Good, 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 good. This is a very slow fall down. Sad to say. It is not at all what I remembered programming in the past. So I've definitely definitely need to fix whatever that is. We don't even have intersection. So this is definitely something I'm going to have to think about, and yeah, we'll get back to this, and hopefully I will have brainstormed a little bit and thought of how I actually did it last time I made this. It's been deleted since, so that'll have to do it for the episode right now. Sorry it was a complete failure. We did get something kind of functioning, but I don't want to complete it with the testing for intersection or anything, because it just seems like it's a little too slow to be any fun. So yeah, I'm gonna try to think about it. Hopefully I'll have the time to make another episode, but for now this is all we can stick with, and I will see you later.